Let's go to page 243 and let's do number 387. Okay, so 387, the picture is giving. Okay, so you have this picture over here, and so this is a L, this is M, this is P, and this is Q. And let's go and put more points. Let's call this A, this B. Okay, so the radius are 6 and 4 respectively. So this is 6, and this is a 4. Okay, and you're looking for LM. Okay, the LM. So you're looking for the length of that. Okay, so what we need to do first is let's go and draw a whole bunch of points. Okay, so first let's go and draw the radius. Okay, next let's go and draw another big radius. So the diameter is 20. So your radius would be 10. So it'd be right over here. Okay, and we're going to draw the perpendicular to that. Okay, we're going to call this point O. And let's go and label more points. Let's go and call this D, E, C, and F. Okay, so what we're going to do is we're going to turn this triangle let's go and call this G over here. So if you look at this triangle, the long skinny one, okay, so it's easier to see if you turn it sideways, if you turn it this way. Let's go and do it this way. Okay, so you got G, and then you have the FQ, okay, and then you have the EO, that's this one here, and you have the DP. So we're going to put some numbers on there. So notice from P to O is 6. From well, actually it's 4. From P to O is 4, and from O to Q is 6, and from P to B is 4. And what else do we know? Oh, okay, so this is also 6, so we know this is 6. Okay, so this is like a similar triangle. And FQ is 4. So FQ is 4. Okay, so we're going to look at this one over here. So FQ over DP, so this over this will equal to, so we're looking at this triangle versus the big triangle. Okay, so we're equal to GQ over GP. And this will also equal to okay. Now you can actually figure out this very quick. Okay, so you got FQ. Okay, so you got 4 over 6 equal to GQ over GP. So we don't have that much, but one thing you can see is that this is equal to 10. Okay, so see over here? So from 6 to 4, you're dropping the 2. So if you go down by 2, this is 10. So from here to 0 is 4. So this would be a 20. Okay? Or you can just go and call it X. So this would be, so 4 over 6 equal to GQ over GQ plus 10. Okay? Then you can cross multiply. So you got 6GQ equal to 4GQ plus 40. And then you subtract, so you got 2GQ equal to 40. So GQ equal to 20. Okay. So once we do that, we can figure out this part over here. Okay, EO. So EO, so this over that over 26, right? EO, so the bottom over the side equal to the bottom over the side. So EO equal to 26 times 6 over 30. So EO equal to 26 over 5. Okay, so EO equal to 26 over 5. So this, I'm going to put this over here, so 26 over 5. So now what we're going to do is we're going to look at, so this problem is a little bit complicated. So we're going to look at, so once you find the EO, okay, then we're going to look at this triangle. We're going to look at LEO. So EO is 26 over 5. And LO is going to be the radius of the big semicircle, which will equal to 10. Okay? Right, because the diameter is 20, so half of that, the radius would be 10. Okay, so again, OL is the radius of the big semicircle. Okay, so now we can use the Pythagorean theorem. So A squared plus B squared equal to C, A squared plus B squared equal to C squared. So you got 26 over 5 squared plus LE squared equal to 10 squared. Okay, so you got 76 over 25 plus LE squared equal to 100. And subtract that from both sides. So LE squared. Okay, you can use your calculator to subtract to figure it out. So you're going to get 1824 over 25. You take the square root. So LE will equal to 4 square root of 114. So you can do this off on the side. Okay, let's do that. 1824 divided by 2, you get 912. Divided by 2, you get 456. Divided by 2, you get 228. divided by 2, you get 114. And from here, if you try to do more, you're going to get 57, 3, get 19. So only this thing comes out. So you get 2, 2, so that's 4, square root of 114. And over 5. Okay. Okay, so once you find LE, the chord, when you draw the perpendicular radius to the chord, this will bisect the chord. Okay, so LM would be just twice as that, so it would be equal to 8 square root of 114 over 5. Okay. So this one takes kind of time you have to kind of go slow, step by step. Okay, let's go to the next one. Okay, so read through the problem and the picture is giving. So this is actually a classic problem of equilateral triangle inscribed in equilateral triangle inscribed in a square. Okay, so the problem does not give you this part over here. Okay, so this is what you got. So you have the R, you have the P, and you have the Q, and you have the H. Okay. And this is A, this is A. So you have the ladder with the length of A, leaning again this way, leaning again this way. And so you make a 45 degrees here and 75 degrees over here, and this is 15 degrees. Okay. Okay. So if you look at over here, this will give you 120. So this will be 60 degrees. Okay. And if this is 60 degrees and this is the length of the ladder, this is the length of the ladder, so these two are congruent. So that means these two angles have to be congruent. And see, this is 60, so these two are equal to 120, and therefore have to be 60 and 60. Okay. Once you figure out this is 60, if you draw a complete square to that, you can see that this would be a 75, this would be 15 degrees. Okay. So if this is the H, this would be the H. Okay. And so you're looking for the width. Okay. So if you recognize that this is a square, so if this is the H, well actually the distance K above the ground, so here's a K, but you don't really care about K because this is going to end up with a square. So if this is going to be the H, the width, the W will also equal to H. Okay. And that's it. Again, if you look at it, it's a symmetrical. So this is H. This is also H. Okay. So a lot of times, it's kind of hard to realize that. Again, this problem shows up quite often, the linear ladder problem. Okay. So when you have 45 and 75, okay, it's actually an equilateral triangle inscribed in the square problem. Okay, and so this will be equal. Okay, let's go to the next one. Okay, so 389, the picture is giving. So this is D, C, B, A, and this is E, and this is F. Okay, and it tells you that BF equal to 4, and DB equal to 20, so DB equal to 20. So if this is a 4, this would be a 4 over here, and this is 20, so this would be a 16. So 16, this would be 8 and 8. Okay, so again, this is 20, and you already taken a 4 for the radius, so it would be 16 over here, so it would be 8 and 8. Okay, so from there you have to figure it out. Okay, then after that, you're looking for AE. Okay, you're looking for AE. Okay, whenever you have this kind of problem, okay, what you need to do is go ahead and divide the trapezoid into a rectangle and a square. So divide this up. So this would be an 8, and this would be a 4, and this would be a 4. Okay, so now you can go and figure out the EF. So this would be, so this is 4 and 8, so this would be a 12 over here. So you have a triangle that looks like this. So you got C, B, and let's call this point Q. And so you got 4 and 12. So use your Pythagorean theorem. So QB square, well, that's just QB. QB square would be the 12 square minus 4 square. Okay. So QB equal to square root of 144 minus 16. So QB equal to square root of 128. So QB equal to 8 square root of 2. Okay, so QB is going to be 8 square root of 2, and so this would be 8 square root of 2. Okay, so next step, what we need to do is to figure out the AE. Okay, so you can use the similar triangle. Okay, so that's going to do, so you got AE over CE. So AE over CE. So you got, so look at this one. So you got the long leg over the short leg equal to BQ. So we're looking at this big triangle and this small triangle right over here. So equal to BQ over QC. Okay, so again, looking at the big triangle and this small and this small triangle right over here. Okay, so AE is the long leg over short leg equal to the long leg over short leg. Okay, so AE is what we're looking for. CE is 8. BQ is 8 square root of 2. And QC is 4. Okay, so multiply by 8. So AE equal to 16 square root of 2. And that's it. Okay, let's go to the next one. Okay, so a triangle is inscribed in a circle. Okay, so that's going to draw a big circle. Okay, and then a circle with center I is inscribed in that, so you're looking for an inscribed circle. Okay, so the center over here, and then this is gonna go through that, and this is the I. Okay, so AI is drawn and extended so that it means at D. So you want to prove that D, you want to prove that this is the center of the circumscribed triangle. So basically you want to prove that this is the center of the circle that's circumscribed around this over here. So something like this. Okay, so you want to prove that this is the center. Okay. Since this is inscribed circle, so the line that goes through the center will be the in center. So this will be the angle bisector. Again, to get the angle, to get all the lines that go through the in center will be the angle bisector. Okay. So so the same thing over here. So that's going to call this phi, angle phi, and this would be angle. Let's call it theta. Okay. And this would be also congruent, but we don't need that for now. Okay. Okay. So again, AI is the angle bisector. Okay. So angle CAD is congruent to angle BAD. So CAD is congruent to BAD. Okay, and we're going to call both theta. Okay, now because of that, because these two angles are congruent, therefore the arc would be congruent. So CD is congruent to BD. Okay, because again, because these two are congruent, so they will subtend congruent arcs. Okay. And then you have DC equal to DB. Okay, so that's going to draw the chord. Okay, because again, when you have the congruent arc, we have the congruent chord. Okay. And it's going to be important again to prove that this is the center. This will equal distance to that, to that, to that. So right now we got 2 out of 3. Okay, so this is going to be important later on. Okay, so again to prove that this is the center, then it must have an equal distance to all 3 points. So right now we got these 2 congruent. So all we need is 1 more to go. Okay, okay. And after that we got angle DCB is congruent to angle DAB. Okay, so angle DCB, this angle right over here. Okay, now this angle will also equal to phi. Okay, because it subtend DB. Okay, because the DAB subtend this over here, and DCB subtend the same arc. Okay. Okay, they are congruent because they subtend the same arc. Okay. And then you have the angle ICD is equal to angle CID equal to theta plus phi. Okay. So ICD, oh wait, this is theta. Okay, this is theta. Okay. Okay, so angle ICD is equal to CID. Okay. And the reason that the CID we use exterior angle. This one we use the exterior angle theorem. The exterior angle equal the sum of the two interior angles. So this is equal to theta plus phi. Okay. So again, we're using the exterior angle. So the exterior angle equal the sum of the two interior angles. And this one we just kind of look over here. Okay. So once we see that these two angles are congruent, okay, then we have DC equal to DI, okay, and because they're facing congruent angles, okay. Okay, so now these two are congruent, okay, and so now again this is important. Okay, so after that, then we can see that combining these two, we have DC equal to DI equal to DB, and all these are equal to radii. Okay, so therefore, D is circumcenter of triangle CIB. And that's it. Okay, let's go to the next one. Okay, so 391, the picture is giving. You got A, B, C, D. And you have the midpoint. So this is the E, and this is the M. Okay, and then back up. This is one. Draw it wrong. Okay, it's supposed to be this way. Okay. Okay, so ignore this line over here. And this is Q, and this is P. Okay, so each side has a length of 12. Okay, and E is a point on DC is 5 from the D, so this is 5. So that way this would be a 7. And so it tells you that this is perpendicular. And you find the ratio of PM to MQ. Okay, so what we need to do is go ahead and draw a parallel line. Okay, so from here, RM. Okay, so this is 5 and this is 12. So, and since this is the midpoint, this should divide into also the midpoint. Okay. So that right away, this would be a 6. This would be a 6. Okay. So RM equal to 1/2 DE. Okay. and here's the R. So we label this R and label this S. So RM, because this is a triangle, and if you go to the midpoint, if you draw a parallel line to the midpoint, this would be half of that. So this would be a 5 over 2. So RM will equal to 5 over 2. Okay. And once you find out RM equal to 5 over 2, and by the way, you can kind of use a ratio. Okay. So this would be a 5, 12, 13 ratio. So you can use this and this, you can get that this is 13 over 2. Or you can just half, right? 5, 12, 13, and it'll be half, so it'll be 13 over 2. So you got 5, 12, so this will be a 13, and this is the midpoint, so it'll be 13 over 2, 13 over 2. Okay, then after that, you can go and do the MS. So MS, so this part over here is equal to the 12 minus RM. Right, so 12 minus RM will give you the MS. So MS equal to 12 minus 5 over 2. So MS will equal to 19 over 2. And if you look at the scale factor, so this is the 19 over 2. So look at the scale factor of these two. It would be 19 over 5. It would be 19 to 5. Or 5 to 19. So you can look at these two blue triangles. So it'd be 5 to 19 over 5 over 2 to 19 over 2. Okay, so it'd be 5 to 19. So PM over MQ will equal to 5 over 19. So you can use your scale factor, so you don't even have to actually figure out the actual length. Okay. Okay, let's go to 392. Okay, so read through the problem. So a triangle is formed by congruent points contact on the side of the triangle and the in circle. Okay, so you got A, B, C, and the point would be F, E, and D. Okay, prove the new triangle is acute. So we want to prove this is a acute triangle. Okay, so angle EDF equal to 1/2 of the arc EF. So EDF, so this angle right over here, okay, it's 1/2 the arc, and angle A would be this arc minus arc divided by 2. Okay, it would be EDF minus EF over 2. So angle A equal to 360 minus EF over 2. You simplify, so angle A will equal to 180 minus EF. Okay, so because this you just simplify this, you get that. Okay, and then now EF, if you notice that EF is going to be twice the angle EDF, because inscribed angle is half of that. Okay, so angle A would be 180 minus 2 times angle EDF. Okay, because the inscribed angle is half. This would be twice of the inscribed angle. And so you just do math, do simple, move things around. So you got 2 angle EDF equal to 180 minus angle A. Then you divide by 2, so angle EDF equal to 90 minus 1/2 angle A. Now since angle A is positive, so 90 minus something will give you less than 90. So angle EDF is less than 90 degrees. Okay? And so you can just rotate. So similarly, angle DFE is less than 90 degrees. Okay? And similarly, angle FED is less than 90 degrees. So once you prove one, you just keep rotating.